For topic 5, we're going to determine if vectors are orthogonal. Okay, so you know my rules about a definition at the beginning of a video. Orthogonal also means perpendicular. Okay, so two vectors are orthogonal if the angle between them is pi over 2 or 90 degrees. And that kind of should make sense because if you go back to like early days in your math career, I mean, like we're talking middle school, okay? You would have learned about lines being parallel and lines being perpendicular. And what we learn is that two lines are said to be perpendicular if they intersect, forming right angles, so 90-degree angles. So not the same thing, but there's like a similarity in what we're talking about there, okay? Now, just like with parallel vectors, we knew that vectors were parallel if the angle between them was either 0 or 180. And then we were told, hey, also, by the way, two vectors are parallel if one is a scalar multiple of the other. Well, we have kind of this extra little bit of information here too. So two vectors are perpendicular or orthogonal is what we would say if the angle between them is 90 degrees. But we can also say that two vectors are orthogonal if and only if their dot product is 0. Okay, so whoa. Okay, now remember, when we're talking about the angle between vectors, we have this. We know that cosine of the angle between two vectors is equal to, let's say we're using u and, well, we have v and w here. So cosine of this angle is going to be equal to v dot w over the product of the magnitudes of v and w. Okay? Well, if a dot product is 0, that would make this numerator 0. So if this equals 0, then we would get cosine of theta equals 0 over these magnitudes. But what happens if we have 0 divided by a number? Because remember, magnitude is just a value. So like the magnitude is literally just the length. It's like a scalar, okay? So if we have the product of two scalars, we just get a scalar. So we're going to have 0 divided by some number. That just tells me that cosine of theta equals 0. Well, when does cosine equal 0? Cosine equals 0 at pi over 2, okay? So here, theta is pi over 2, or 90 degrees. So it kind of makes sense that if our dot product is 0, we're going to have a situation where we have perpendicular vectors or orthogonal vectors, because if the dot product is 0, if we take this angle between vectors theorem and we plug in 0 for the dot product, we're going to get cosine of theta equals 0. Well, cosine equals 0 when theta is pi over 2, okay? So we have two ways that we can test here. We can find the angle between them and make sure it is 90 degrees, or we can check their dot product. If the dot product is 0, we have perpendicular vectors. Okay, so for example 7, it says use the vectors v equals 2i minus j and w equals 3i plus 6j. So you know how much I love component form of vectors. So let's go ahead and get rid of it. All right, so we're going to say v has horizontal movement of positive 2 and vertical movement of negative 1. And W has horizontal movement of 3 and vertical movement of 6. Okay, I just like that form better. All right, so for part A here, it says draw a sketch of the two vectors to see the angle theta. So we can't draw the two vectors and be like, they're for sure perpendicular, but we can get a really good idea. We probably need to do something a little bit more mathematical to verify that the two vectors are perpendicular, but starting with a sketch is never a bad idea. All right, so let's do vector V in red. So we're going to start at the origin. We've got this position vector 2, negative 1. So at the origin, I'm going to go to the right 2. That's my horizontal movement. And then I'm going to go down 1. That's my vertical movement. So this is my vector V. Okay. Now let's do W in blue. Okay. So W, let's see, we have the position vector 3, 6. So at the origin, that's my initial point. My horizontal movement is positive 3, and my vertical movement is positive 6. So 1, 2, 3, 4, 5, 6. So I get this vector here. Now, looking at these two vectors, it certainly looks like this angle is 90 degrees, but we need to double check. So we're going to double check and make sure theta is 90 degrees or pi over 2 radians, okay? So keep in mind, this is not like drawn as it would be in the unit circle, so don't think like that, okay? We're looking for this angle between these two vectors, okay? So be careful. Now for part B, it says find v dot w to determine whether the vectors are orthogonal, okay? So remember, when you find a dot product, you're taking the A components, multiplying them, you're taking the B components, multiplying them, and then adding, okay? So V dot W would look something like, well, the A component of V is 2. The A component of W is 3. The B component of V is -1. And the V component of W is 6. So we get 2 times 3 is 6. And then we get plus -1 times 6, which is -6. You could have also just thought of this as 6 minus 6, which is, ta-da, 0. All right, so we definitely get a dot product of 0. And so that should make sense if we wanted to go ahead and find that angle, okay? Like if we wanted to find the angle between these two vectors, we would say, okay, well, we have cosine of theta equals the dot product of V with W. So that's just going to be 0 over the magnitude for V times the magnitude for W. Well, the magnitude for each of these is just a number. So we're going to get cosine of theta definitely equals 0. And we know that theta would have to be 90 degrees. So when the dot product is 0, you have a situation where these two vectors are certainly perpendicular. The angle between them is definitely going to be 90 degrees. Okay, so that is how to test to see if two vectors are indeed perpendicular. Okay, the last video, I'm not going to do it now. I'm going to wait until tomorrow, so I'll be a little bit fresher, hopefully hydrated, rested, showered, okay? But the last part of this worksheet is on work. So this is where we get to like kind of do some applied stuff. So think like word problems, okay?